right, here's a new intro made by one of our students, Andrew. Thank you so much for that, Andrew. All right, so let's see if I can get back to where I want to be. There we go. So today I'm going to talk about direct variation today. And direct variation has one main equation, and it's this one here. You should write this on your formula sheets. Right on formula sheets, write them both on there. And it's y equals kx, and this is actually the same equation on the right, just manipulated. Y over x equals k, all right? K is called the constant of variation. It's really like slope. You could think of that as y equals mx. So that's the main equation, and with this, these type of problems, if you can find out what k is, that's really the name of the game. All right. If you find out what the constant of variation is, you can find out everything else. So let me, once I've written that down, the first thing is I'm going to ask you guys to do is simply to identify whether something is actually a direct variation or not. So I'm going to, are these direct variation or not? So I'm going to list some equations. Number one is y equals 3x. Two, y equals 1/5 x. 3, 4x equals 8y. And I got 5 of them. 4 is y equals 2x plus 1. And number 5 is 2x plus 4y equals 8. Okay. Excuse me. So if I can manipulate this equation and fit it into y equals kx, then it's direct variation. If it's anything other than that, and k can be any regular number, in this case, this is exactly the same where k equals 3, which means, yes, that's direct variation. This one is also direct variation. There's the slope is 1/5, which is k. The constant, if they were to ask what is the constant of variation, you would say it is 1/5 in number 2. So that's also a yes. Now this one, I don't have y alone. If I can get y alone, then it's really easy to analyze the equation. If I took this equation and I divided both sides by 8, I would get y equals, because 8 divided by 8 is 1. 4 divided by 8 is 1/2 x, which means, yes, this is also constant. Oh, it is direct variation. I use dv as a abbreviation. And if they were to ask for what is the constant of variation, you would say 1/2 or 0.5. Same thing. This one, a little different. This plus 1 over here messes the whole thing up, which means it's not direct variation. So anytime it's got, y equals something times x plus something, the plus something messes it up, or minus something, it could be -6. It is no longer a direct variation equation. Questions so far? If you do, write them down, bring them to class. All right, this one, I'd like to manipulate this equation so I get y alone. Okay, so the first thing I'm going to do is subtract 2x from both sides. And I get 4y equals 8 minus 2x. Next thing I'm going to do is divide everything by 4. And when I do that, I get y equals 8 divided by 4 is 2. 2 divided by 4 is 1/2. I'll do the reducing in my head there. You could put 2/4 x. Now if I was to rewrite this, so I put the x first, that would be -1/2 x, remembering the subtraction sign. there stays with the variable, not with the 2. So it's negative 1/2 x plus 2. So once again, this is not direct variation because this plus 2 changes it around, okay? Okay, so those are the first things I wanted to go over. Just identifying the direct variation. Number 6. Suppose y varies directly with x, and y equals 35 when x equals 5. Write a direct variation equation. And the second part of the question is, what is the value of y when x is 9? Okay, so this one, I'm going to start with my equation, y equals kx. That's the nice thing about this section is you've got an equation to work with. Now, the first part is I got, y equals 35 and when x equals 5. So if I plug those two values in, I can find out k. Remember, I said in the beginning, finding out k, that's the name of the game. So I know that x equals, change colors here, x equals 5 when y equals 35. So if I plug those two values in, I can find k, and I'm going to keep the k there. Okay. So now I'm in good shape to find out what k is. All I have to do is divide both sides by 5, and I'll get my answer, k equals 7. Now the equation in the first part of the answer to the first part of the question is where it says, write a direct variation equation, y equals 7x. So that's my first answer. Not the only one, because the second part of the answer of the question asks for what is the value of x when y, that must be a typo, sorry, this is supposed to say the value of y when x is 9. Sorry for that, fix your notes. What's the value of y when x is 9? Okay, so back to this. Now I know what x is, I have the equation. So x equals 9 and y we don't know. Okay, but I have the equation, I know k is 7, therefore if I plug in the 9 for the x there, I get y equals 7 times 9. 7 times 9 is 63, and that is what y is. And there's my second answer. If you have questions, write them down, bring them to class. Let's try another one. Maybe you should try this one. Number 7. It's the same kind of problem. We'll do a you try. Suppose y varies directly with x. And y is 10 when x is negative 2. Write a direct variation equation And the second part is what is y when x is 6? Okay, so you should hit pause right now, try that on your own, see if you can get the answer, and then come back. Alright, so I'm not going to hit pause because I've got the answer. So y equals 10 when x equals -2. That's the first thing. I got this out of the information. And then the second part will be over here when, what is y when x is 6? So I'm using that same equation, y equals kx. Y is 10, x is 2. Got to find out what k is. Remember, that's the name of the game. So if I divide both sides by 2, I get k equals 5. So my equation is y equals 5x. That's the first answer. And then over here, I'm going to go and figure out what y is when x is 6. So y would be 30 when I plug it in. Okay. And there it is. If you have questions, please write them down, bring them to class. Love to see more questions in class. Number 8. Suppose y varies directly with x. And y is 36 when x is 12. What is y when x is 6? Alright, so y equals kx. Over and over again. Y equals kx. And these two go together. So y equals 36 when x is 12. Over on the other side, x is 6, and they're asking what is y? And x is 6. Alright, so if I plug the 36 and the 12 in first, 36 equals k times 12. Divide both sides by the 12 to get k alone. And I get k equals 3. Okay, so the equation, this one actually doesn't ask for the equation, but the equation is y equals 3x. Okay, now I'm going to take the x equals 6 and plug it right in there. And I'll get y equals 3 times 6, which is 18. And that is the question that the answer to the question they're asking. Okay, so we've done enough of those. Let me move on to the next kind of problem that you're likely to see. I got 2 of these, and that's it. I believe on question 9. Question 9. For the data tables below, does y vary directly with x? For the data tables below, does y vary directly with x? If it does, what is the equation for direct variation? Variation. Okay, so I got two tables. And A is this one. Here's my X, here's my Y, and I got 4, 8, 10, and over here in the Y column I got 6, 12, 15. Alright, so I'm going to do this one first. Now there was the other equation too. There wasn't just y equals kx. The other equation was, it's really the same thing, and I'll show you. The other one was k equals y over x. And I'll show you how I got that. I can take the other equation and manipulate it. If I took y equals kx, and I want to get k alone, I would simply divide both sides by x. And I'd get k equals y over x. So you can see that that's actually the same equation, just manipulated like that. In fact, there'd be a third one too you could use. But these are the two that we'll be using for now. All right, which means if I take these values in the table, the x's and the y's, and I would take y and divide it by x, what do you get? If you get the constant of variation, the same number for all three division problems, then it's direct variation. If you get anything other than the same number, then it's not. So let me show you what I mean. So y divided by x, that's 6 divided by 4. It's 12 divided by 8. And the third one would be 15 divided by 10. These have to all be the same thing. In this case, 6 divided by 4 is 1.5. 12 divided by 8 is 1.5. 15 divided by 10 is 1.5, which means, yes, it's direct variation. And here's the step, one step bigger. They asked for the equation, which means I need k, and it's no surprise that k is 1.5. It's whatever that y divided by x turns out to be, just like when you plugged it in here. Which means the equation is y equals 1.5x. And there you go. If you have questions on that, bring it to class. I'm going to move on to the letter B, the last problem here. And same directions. Table, I got -2, 3.2, 1, 2.4, and 4, 1.6. Okay, so if I start dividing that same equation, y over x equals k, and I take 3.2 and I divide it by -2, and then I take 2.4 and I divide it by 1, and then last but not least I take 1.6 and I divide by 4. What do you get? So this one, 3.2 divided by -2 is -1.6. 2.4 divided by 1 is itself. Anything divided by 1 is itself. 1.6 divided by 4 is 0.4. So these numbers are not the same. They're not all equivalent. Like up in the previous problem, they all equaled 1.5. Not direct variation. Does not have a constant. And that's it. You can't figure out what k is if it's not direct variation. So you're done with the problem, and you move on. All right, so that wraps things up for today. Once again, if you have questions, please bring them to class. Thank you very much for watching, and see you all tomorrow.